Okay, so let's go ahead and use our identities to basically find some exact values of items. In the first round, we got the cosine of 165. So what we're trying to think of is what angle, right? How can I rewrite this? This is cosine of what angle all divided by 2, right? Or effectively, if you just double that. So if we took 165 and doubled it, we get 120, we get 2, that's this 165, 165, 0, carry the 1, 3, 1, that's 330. So we're basically looking at the cosine of 330, right, divided by 2. So that's another way to write 165. Of course, now that I have this, this is basically plus or minus the square root of 1 plus the cosine of 330 degrees all over 2, right? And all I'm doing is invoking, now that I have written it in terms of a half angle, right, I can invoke my half angle identity. And so what happens next is we have plus or minus. We're talking about 1 plus, well, 330 degrees, right? That is basically 30 degree reference in quad number 4. Right, if I draw a picture. And so we're basically looking at that situation. So we're looking at the square root of 3 over 2 all over 2. And that right now is a train wreck. So there's basically the trig. All right, so rewrite this function in terms of its half angle. So what angle are we taking half of? In this case it's 330. I invoke it, and then I use my in this case I used a right triangle. You can use your unit circle, whatever you can recall to get that. But now the challenge is how do I simplify that guy right there? So let me go ahead and go to another sheet of paper to kind of extend that out. So we're trying to simplify. We have plus or minus the square root of 1 plus the square root of 3 over 2 all over 2. And I'm going to invoke an old trick that I've been doing quite frequently is how about I multiply the top by 2, and whatever I do to the bottom, I also multiply it by 2. So my balancing is do whatever I do to the top to the bottom. So we end up with plus or minus. If we distribute the 2 out here, we get 2 plus the square root of 3, and then all over 4. And then this time, right, we can take the square root of the top and the square root of 4, which turns into plus or minus the square root of 2 plus the square root of 3 all over 2. All right, and then last but not least, are we talking about the plus or minus? Well, let's go back to the original guy, 165. 165 actually occurs in quadrant number 2. And we know that the cosine is less than 0 there. So we need a negative square root of 2 plus the square root of 3 all over 2. So there would be our exact value of the cosine of 165 degrees. All right, for this situation. And unfortunately, there's no way to simplify this radical because we're summing, and you can't break up a radical over a sum. All right, so some of you have been doing that. I keep marking you wrong, and hopefully we've learned by this time because that's our exact answer. We have a radical within a radical, so pretty crazy. So the next one, we're talking about sine of 5 pi over 8. Again, since we're talking about half angles, we got to kind of think what angle can I divide by 2? Right, so sine of what angle divided by 2 gives me that. And so we're basically trying to figure out when does theta over 2 equal 5 pi over 8. And so if we multiply both sides by 2 and do a little dividing out, we end up with 5 pi over 4. So we're looking at sine of 5 pi over 4 all divided by 2. So now I've written it in terms of a half angle. So what's our half angle formula? Well, it's this guy here, right? So we got plus or minus the square root 1 minus the cosine of 5 pi over 4 all divided by 2. And if we go one step further, before we have to do some more work, we have plus or minus the cosine of 5 pi over 4. Well, that's in quadrant number 3. And so we have a negative square root of 2 over 2 all over 2, and that's a negative. So now, right, there's the math. A negative times a negative is a positive. So let me go ahead, since there's much more simplification to do, we're basically looking at plus or minus the square root of 1 plus the square root of 2 over 2 all over 2. And again, I'll use that famous trick. Rather than adding and subtracting my fractions, how about I multiply both top and bottom by the same thing, in this case 2. And so we get plus or minus. If we distribute this out, we get 2 plus the square root of 2 all over 4. This is all under the radical. So breaking this up, this is the square root of 2 plus the square root of 2 all over the square root of 4, which turns into plus or minus the square root of 2 plus the square root of 2 all over 2. Plus or minus, which one do we want? Right? Well, essentially it comes back down to where's 5 pi over 8. And I do know that 4 pi over 8 is pi over 2, right? And I know that 8 pi over 8 is pi. So this tells us that 5 pi over 8 sits in between. So we are in quad 2. So what do we know about sine in quad 2? We know that it's positive. So we have this square root of 2 plus the square root of 2 over 2. That's basically your sine of 5 pi over 8. Right, there's your exact value for that guy. All right, so again, at some point the trig's done, right? Then it just comes to simplifying some things using some algebra, and hopefully you guys appreciate that trick. All right, so last but not least, we have the tangent of 67.5. So we're basically trying to figure out what angle can I divide by 2 to get 67.5. I guess I should have done it at the beginning. If I multiply both sides by 2, right, the angle that we're looking for, I believe, is 0, carry the 1, carry that's 12, 135. So we're talking about the tangent of 135 degrees divided by 2. All right, and then what's interesting about this is we actually have several different choices, right? And so how about, let's not do that one, because radicals, how about, we've had enough radicals for the moment. So how about we choose one of these two? And I'm actually going to choose that one because here we have a sum, and simplifying a sum can be difficult sometimes. So why don't we just go ahead and go with the singular? So I'm going to rewrite this as 1 minus the cosine of 135 divided by the sine of 135. Okay, and then what do we know about 135? Well, we know that that's in quadrant number 2. All right, and so we have 1 minus negative square root of 2 over 2 all over the square root of 2 over 2. And so now we've got to clean that up. So upstairs, when we subtract a negative, we have 1 plus the square root of 2 over 2, and we're dividing by the square root of 2 over 2. Again, to simplify a complex fraction, I'll multiply both top and bottom by the common denominator. Distributing up here, we end up with 2 plus the square root of 2. Down below, the 2's cancel out, leaving us with square roots of 2. And so now what do I have to do is I have to rationalize my denominator. So we end up with, distributing up here, we end up with 2 square roots of 2. Square root of 2 times square root of 2 is 2. And then square root of 2 times square root of 2 is 2. And I have a bunch of 2's everywhere. So this simplifies to the square root of 2 plus 1. So there's the value. There's the exact value of the tangent of 67.5 degrees. And we're off and we're running. All right, so there you have it. So again, the trick to using these is trying to figure out the angle that's being halved. Perhaps setting up a little, here I kind of did it in my head. Over here, I actually set up an equation and found the angle. And then once I found the angle, I can rewrite the expression in terms of its corresponding trig identity. Use the unit circle to replace what we know about the cosine of 330, or the cosine of 5 pi over 5, or the cosine of 135, the sine of 135. And then once I make that replacement, it's now just a bunch of algebra, right? Trying to simplify that answer as much as we can. And hopefully the way that I'm trying to show you guys to simplify, we call this a compound fraction. We have a fraction within a fraction. And to me, the easiest way to simplify it is to multiply both top and bottom by the LCD to get rid of everything all in one whack. and then we just keep simplifying and go as far as we can. All right, so there's some first round of exact values. Now, right, we'll kind of go to that conditional problem where we're given some information, and how do we find the exact value of a trig, an unknown trig value. So we'll do that in another video coming soon, because we're already 10 minutes into this guy. So see you guys in a bit.